Hi, welcome to my video presentation. Let me start by saying a few words about myself. I'm Jamaica Badila, second year college with the course of Bachelor of Science in Information Technology, or BSIT. As you can see on the screen, my topic is quicksort algorithm. My talk is particularly relevant to how quicksort algorithm works. So if you want to know how does it work, just watch this video.
So what is a quicksort? Quicksort is a divide and conquer algorithm. A divide and conquer algorithm is another type of algorithm techniques na pwede natin gawin sa mga programs natin. And quicksort, we are going to partition the array and recursively sort each piece of the partition. So basically, kapag nakagawa na tayo o na-partition na natin yung array natin, parang ganito ang style niya. Wherein we have the less than p na part and we have p wherein p is called as pivot and the greater than p na part. Doon sa mga elements ng array natin, mamimili tayo ng p or the pivot and lahat ng maliliit na value doon sa p na nandun siya sa left part and lahat ng malalaki ang value kaysa kay p doon siya sa right part or partition. So let's say we have this array. When we are using the quicksort algorithm, always think of this element wherein we have the p as the pivot, meron din tayong lesser value. So let's say L na lang muna and higher value which is the H. Marami tayong way kung paano piliin si pivot. Pwede siya yung first element, pwede din yung last element or middle element. Or pwede natin i-add si first element plus last element and divided by 2. Pwede yung mga way na yon. So in this example, we're going to use 5 as the pivot. Tapos meron tayong lesser value, always andito siya sa left. So 6 na lang ang lesser value natin. So, bakit hindi ang first element ang lesser value? Dahil si first element ay si pivot. And the higher value, of course, dapat parating nasa right. So, last element naman natin is H na yon or higher value. Now, if you are using quicksort, we're going to follow this simple algorithm. Wherein if the element of L is less than P or the pivot, increment the index of L. Then, if the element of H is greater than P, decrement the index of H. So, kapag false yung dalawa dun sa taas, meron naman tayong else if the element of L is greater than the element of H, we're going to swap. Then, increment the index of L and decrement the index of H. If the index of L is greater than the index of H, stop na po yung partition. So, using this as simple algorithms, gagamitin natin ngayon siya dito sa array natin. So, first, identify muna natin if the element of L is less than P. So, element of L is 6. 6 less than 5, that is false. So, walang mangyayari. Then, we have an element of H is greater than P. H greater than 5, that is also false. So, kung false tong dalawang to, we have the else if the element of L is greater than H, magsaswap daw po sila. So, 6 greater than 3, that is true. So, pag true siya, magsaswap yung dalawa. Pag nag-swap na sila, magkakaroon tayo ng bagong arrange ng array. Kung titignan natin, nagpalit sila ng location. Andito na si 3 and andito na si 6. Then, after swapping, increment the value of n. Kapag nag-increment siya by 1, so magiging 2. Andito na si L. Then, i-decrement the value of H. The value of H here is 6. Kapag nag-decrement tayo ng isa, magiging 5 na lang po siya. So, ibig sabihin, nandito na si H. So, now, identify if L is greater than H. So, 2 greater than 5. We're talking about the index. Kaya index 2 greater than index 5 is false. So, hindi pa tayo nag-i-stop. Ibig sabihin, babalik tayo sa taas na step. So, identify again if element of L is less than P. So, 2 less than 5, that is true. So, pag true daw siya, increment the index of L. So, mag-i-increment itong L na to, magpa-plus 1 siya. So, ibig sabihin, mag-move siya dito. Now, identify again if L is less than P. 4 less than 5, that is true. Increment again the value of L. So, mag-move ulit yung L, lilipat ulit dito. Then identify again if element of L is less than P. So 7 less than 5, that is false. Then we have the next condition. If H greater than P, so 1 greater than 5, that is false. So pag false silang dalawa, we have the else. And identify natin if array or element of L is greater than the element of H. So, 7 greater than 1, that is true. Magsaswap daw yung dalawa. So, pag nagswap yung dalawa, we're going to have a new arrangement of array. So, kung titignan natin, nagswap lang sila ng location. Andito lang si 1, andito naman yung 7. Then, after swapping, increment the value of L. So, andito si L. Pag nag-increment siya, lilipat siya ngayon dito, decrement the value of H. Andito si H. Pag nag-decrement siya, ibig sabihin, lilipat siya dito. Now, the value of L is 5 and the value of H is 4. So, 5 greater than 4, that is true. So, true na tong part dito. Ibig sabihin, mag-stop na yung partition natin. So, dahil stop na yung partition natin, isisingit natin si 5, the pivot, doon sa tamang location niya. Ang location niya, kung titignan natin, dito sa array natin, before mag-L, we have 3, 2, 4, 1. These elements are less than the pivot, which is 5. Then, we have 7 and 6. Andito sa right, this is greater than the pivot. So, meron tayo nito, yung mga mas maliit doon sa pivot. We have the pivot and the greater than the pivot or higher than the pivot. So, this is the first partition and the second partition. So, kung titignan natin, hindi pa talaga siya arrange. We're going to repeat again this partitioning hanggang ma-arrange po yung array natin. Kaya po siya tinawag na divide and conquer. Kasi kung titignan natin na divide, tong part na 'to, meron tayong dalawang partition. Itong part na 'to, i-di-divide mo ulit 'to, another partition. So, kaya po siya tinawag na divide and conquer kasi we're going to divide the I hanggang ma-arrange po siya either ascending or descending order. So, we have this algorithm or sample code in partitioning. Of course, kapag nagpa-partition tayo, kailangan natin yung array. We're going to set the low or the lower element or value and the high value. So, from the array, kukunin natin dyan yung pivot natin. So, tulad dun sa example natin kanina, ang kinuha natin na pivot is the lowest index. So, meron tayong array low. Ibig sabihin siya yung pinakamaliit na index or the first element sa array natin, and we have I na lang that will hold the index for low and j that will hold the index for the high. Yung j natin start with low to conquer. Kung mas maliit ba yung laman niya kaysa dun sa pivot, increment yung I and magsaswap yung low and high. So, magko-continue lang yung pag-aas niya ng condition. Hanggang true itong part na to and hanggang matapos niya yung array. So, after the loop, we're going to swap the low and the high. Doon titignan natin yung index kung saan sila nahati. So, para alam ni Pivot kung saan siya sisingit. So, that is the part of the partition. Then, how the quick sort works. So, you're going to conquer yung low and high. As I said earlier, kino-conquer yung low and high hanggang mas maliit yung index ni low kaysa kay high. Ko-continue natin yung magpa-partition. Then, after the partition, mahahati yung array into two parts, to lower value and the higher value, which is yun uli ang ipe-face solve natin para ma-partition ulit sila. And after that, doon sa higher value naman or yun yung mga nasa right side naman ang ipa-partition. So, ayun guys, ganun po gumagana ang quicksort algorithm.